NTU World of Wisdom. Welcome to High Impact Thesis. In this podcast, we speak with researchers from various scientific fields to talk about the motivation, goal, and potential impact of their research. We also want to give you a sense of how a PhD is carried out with an emphasis on the PH, the philosophical aspects involved in pursuing a PhD.
Hello, welcome everyone to the High Impact Thesis podcast. I am Ahmed Hussein, and today I'm hosting the episode with my colleague
Malik.
And our guest today is Jwala. Jwala, welcome to the podcast.
Thank you.
So, can you give us a little introduction about yourself?
Hello everyone, I'm Jwalapuram Pratyusha, or Jwala for short. I was recently a PhD student at NTU, but I'm currently a research scientist at Rakuten.
Great. And you're working on?
So I have been working on evaluation of machine translation. So basically, people may have heard of machine translation. It's basically you use a machine to translate from one language to another. What I did work on particularly was how you evaluate these systems. How do you know that the machine is producing a translation that's good enough?
Okay, is that like a part of machine learning in general?
Well, yes, in the sense that machine translation systems now are built using deep learning. So that's where most of the deep learning happens. But evaluation is a little more complicated. You don't necessarily have to use machine learning for it, but there are ways to use machine learning to make your evaluation better.
So you are just focusing on the evaluation part.
Right. So my PhD particularly focused on evaluation. So evaluation is actually really important. It's something that not everyone realizes, especially when it comes to things like machine translation. These are a little, let's say, models are not very straightforward. So in a lot of cases, you have, this is right and this is wrong. And then you can just check, for example, something like accuracy percentage, right? How many cases are right and how many are wrong, and you just divide by the total or something like that. But it's not that straightforward for machine translation, right? So if you speak two languages, you know that there isn't always an exact translation from one language to another. And there can also be multiple translations from one language to another. So when a machine produces a translation, it's, you're comparing an entire sentence. There are lots of words. There are lots of nuances. How do you tell if the machine is right? You can't just count the number of words that it gets right, because that's not the best way to do that kind of evaluation. Because the machine could use a different word. And let's say usually what you do is you compare against something a human produces, right? So you take a human translation, you check what the machine has produced. And actually, that's one of the main things that I worked on, is what people used to do is to check how many words overlap with the human translation. That's what people used to do. Now, it made sense to do that maybe 20 years ago, but it doesn't make sense anymore. So because 20 years ago, people used rule-based systems, right? They said, okay, if this is the word in English, then this is the word you need to put in French. And then they would have lots of if conditions or something like that. And then they moved on to like probabilities and things like that. But now with deep learning, models are a little more complicated. They're getting very good at certain things, but they're still not very good at some other things. So when you're doing these kind of word overlap, it's no longer good enough, because you can have synonyms. You can have the machine just it changes the order of the words, but it's not necessarily wrong, or it uses the right words and it overlaps with the humans, but then they're in a completely different order, and so it's wrong. And none of these can be caught, right? If you do word overlap, you're not going to know. So it's entirely possible that the machine produces all of the exact same words, but in like a complete reverse order. I mean, this is an extreme case, but you can imagine that happening. And if you do a word overlap, maybe you get a really high score, but the translation is garbage. The human's not really going to understand it.
This reminds me of an episode in Friends. I don't know if you remember that episode.
Oh, the Joey and Phoebe, where he's trying to learn French.
Oh, no, not that one.
Oh.
There was another one where Joey was supposed to write a recommendation letter.
Oh, for the adoption?
Yes.
Okay.
And he uses the thesaurus, and
right.
He does a word for word,
right.
switching, because he wanted to sound
smart. Right. Yeah, that happens a lot as well.
It made no sense.
Yeah.
What he ended up with.
Yes, exactly. So that can happen a lot. So there are lots of words. Language is like redundant on purpose. There are many ways to say the same thing, and there are also like the same word can mean many things. So a machine will not always know which word to use, right? Humans know that because we pay attention to something called context, right? Because this entire you're reading the whole document. You know what was said in the beginning of the document, and then you use that information to understand what comes later in the document. Machines, though, they're not really built to do that. Not yet, at least. People are trying to do that, but it's quite hard to do that. So what happens is that most of the machine translation systems actually translate sentences one at a time. Now, this means that they don't actually have a lot of the information that they need to correctly translate. So a very simple example would be things like pronouns. So let's say we're just talking and I say something like, John lives near the park. He goes there often. Now, when I say he goes there often, you know that he refers to John and there refers to park. Because you heard the previous sentence and you have that in memory, and then you've made that connection already. It's so automatic in human speech, right? But if you don't give machines access to that previous sentence, they don't know what he is and they don't know what there is. Now, this becomes a problem in translation because language is a little bit complicated. So there are languages like French, which have something called grammatical gender. So what grammatical gender means is that English, for example, has something called a neutral gender, right? You have male, female, and then neutral objects. So you have he, she, and it to refer to like men or women and so on. So when you're referring to objects, you use it. So let's say you're talking about a table. You say, if someone says, where's the table? You say, it's over there. Now in French, though, you don't have a neutral it. They only have masculine and feminine genders. So that means that objects are also assigned genders. So table, for example, is female in French. So if you ask someone, where's the table? They may say the equivalent of she is there. Now, if you tell the machine to translate she is there, it's going to translate it to the English she is there. And it's not going to make any sense to someone who speaks English because they don't know what's going on, right? You're looking for a person. So that's going to be a problem unless you tell the machine that, okay, so there is something like grammatical gender. You need to look at the previous sentence and realize that whoever it is talking about a table, and the table's neutral gender in English, and so you have to use it. The thing is, for the machine to learn all this information is not that straightforward. So this is still like an ongoing research in machine translation itself. Now, the problem is that if you do word overlap, if you test a machine's translation through word overlap, the only difference would be that instead of it, you say she, right? So that's just one word. So it look like you have 90% correct translation. And you're going to think, great, my machine's great. It's 90% correct. Except it's completely wrong, right? The information that you've conveyed to the human is not useful at all. It's completely wrong. So the part of my thesis was to show that we need to think of better ways to do this kind of evaluation rather than simply do word overlap, so that you know exactly where the problems are. So one of the reasons you want to know the problems is not just because you need to know how good the machine is, you also need to know where to improve it. So if you don't know that your machine has a problem with pronouns, you're never going to be able to improve it in that direction. So part of the work I also did was, okay, now you know you have a problem with pronouns, how do we improve that? So like a very straightforward thing would be just add more data, right? If you have more data that has pronouns in it, you can give it to the machine so it sees more examples and it can learn. But you don't know what kind of extra data to add if you don't know where the problems are. So part of my work was to show where the problems are and how we find these, and pushing people to do these kind of evaluations so they know where the strengths and the problems of their models are.
Well, that's really interesting.
Okay.
So if we step back a little bit, I imagine the data sets that go into this kind of like network or machine learning algorithm are very different from like you feed it a cat and then you give it a dog and then it knows the difference, right?
Mm-hmm,
so
right.
What kind of data sets are you feeding into the algorithm?
Right. So I think that's one of the bigger problems here, like I've talked about, that we don't have enough data to give the machines. So for machine translation, you specifically need a kind of data called parallel data. So it's called parallel because you need texts in two languages which are exact translations of each other. And you need them to be aligned. So if you have a sentence in English and then you need the exact translation of that sentence in French or German or whichever language you want to translate to or from, and then you need millions and millions of sentences which are aligned that way. So because they're exact translations of each other and they need to be aligned, it's called parallel data, I guess that makes sense. So you need this kind of corpus to train a machine translation model. Now, getting this kind of data is really hard because, it takes a lot of effort to do translation for a human as well. So, and especially with deep learning models, you need data that's in the millions. And that's like 50 million, 60 million sentence pairs and so on. So this data is not easy to get because it takes a lot of effort to, for people to translate money that goes into it and so on. And even with that, like we do have that kind of level of data for certain languages, but we don't have them for all languages. Some languages are popular, like English to French, we have a lot of data. But if you want to look at some languages like English to Malay or English to Tamil or something like that, you don't have enough data. And, I'm considering English being one of the languages, but if you want to do translations like Chinese to Tamil, for example, which is very relevant in Singapore, you're not going to have enough data for that kind of language pair. So it makes it really hard to build good machine translation systems for different kinds of languages. So that's one problem. Another problem is that even if you have this data, finding this data at a document level, which means that you have all of the context that goes with it. Like I was talking about why context is important. So you need information that came before and so on. So to have like this kind of data where full documents are translated parallelly is even harder to get. So then, that's also a major reason why machine translation systems aren't very good at this.
So it seems like there's two paths. So one of them is like context dependent but isolated. So like if I want to convert the phrase, this is a table, to French, then it just needs to know the tables are feminine in French, right? So that's like an isolated context. But then there's another subset of context, or like a parallel context problem, where it needs to know that John was somewhere at the top of the document, and now all of this reference to he is still referring to John. So
yes.
Is that a correct classification?
Sure, yeah. So that's one way to look at it. So yeah, that makes sense. So there's the first kind of context that you talked about, where you know that tables are female in general, is sort of world knowledge, where you expect your machine to have some sort of common sense knowledge about the world, which is what humans generally have. So if I tell you something like, put this on the table, you have this kind of, what a table looks like, and the top, and where it goes, and you have this understanding that objects will sit on tables and not fall down. So all this is sort of common sense knowledge that we have because we've interacted with the world and so on, which machines are not going to have. But then the other context that you were talking about is just information that's local to that particular text. So that's actually, I think, slightly more achievable as opposed to the world knowledge, because world knowledge, of course, it's hard for you to give your model anything of that sort, like common sense, which comes outside of the data that you're giving it, right? So your machine does not have anything, how do I say it? It doesn't have real world knowledge. It hasn't interacted with objects. It has no notion of what objects are. It doesn't know humans from animals and things like that. So it doesn't really know that. It just knows that through examples. So whatever data you give it is all it can learn. So that way, in that way, whatever the local document context is slightly more achievable, because that's data you can give the model, and then you can say, okay, this information is available to you in whatever we've provided, and you just need to learn how to look at it.
Right.
There's this approach in machine learning where you let the algorithm just explore with itself. You just give it a bunch of data. I think it's generally called unsupervised learning, right? You just give it a bunch of data and let it learn. I think the way that AlphaGo is supposed to supposedly learn how to play Go is just by playing against itself like millions of times. Can that concept be imported to translation?
Okay, so this is pretty much a very research question, and it's more about like how you're building machine translation systems. So it could be possible. There have been people who've tried it. They've tried to use reinforcement learning for machine translation systems and things like that. But in general, it's not that successful. It's not as successful as having parallel data and then showing it to the models, because that's a very straightforward signal and much easier for models to learn from. I mean, you could do it the other way, but so far I think people haven't really figured out a way to make it good enough. And even now, with that kind of like parallel data, even with that, models are not very good, which was part of what my thesis was saying, in that, okay, we are still overestimating how good these models are, even given this kind of, very good supervised data.
So what kind of systems were you guys looking at? Like, the first thing that comes to my mind is like just Google Translate.
Right. So Google Translate, is pretty good for most people. Like if you've been a tourist or something and then you wanted to ask like isolated phrases and things like that, it's quite good. But then, if you try different languages, you'll realize that, it starts to fail in certain languages. And then if you give it longer sentences or more sentences, and then it starts to fail as well. So one of the things I was looking at was there are systems which try to use extra information. So they'll try to look at the previous sentence. And then they do all sorts of different things to get the model to look at information that's in the previous sentence. And, what they do is, okay, they say the word overlap has improved with the human translation, so our model is better. And what I was trying to point out is that's not a very good way to evaluate your machines. So what if you specifically looked at how well they're translating pronouns or other things like pronouns which are important in a document context? So there are other things. For example, there are things like consistency. So if you have a document and then you're talking about somebody, you're going to consistently refer to them, through a title or whatever their name is in the same way. The machine translation systems are not very good at translating things like names. So if you give them a name and then you try to transliterate it, for example, to a completely different language, it's possible that each time in a long document, it's going to transliterate it slightly differently. So that happens. And if you do that in a document, then people are not going to know sometimes that it's talking about the same person. So that sort of thing is also important, being consistent in the way you're translating things. So there are lots of different things like this that matter when you're looking at a document level translation. And what I was doing was trying to see is if these kind of models are in fact improving at, translating pronouns, being consistent with their translations, are they coherent at a document level, that sort of thing. So I was trying to build test sets, basically targeted test sets, to see, okay, if you run your system on this particular set of sentences, I can check if your model is actually good at doing all of these things. And then it shows if the model is actually in fact looking at the previous sentences and getting the information it's supposed to be getting.
So how does this contend with something like OpenAI's GPT-3 NLP model?
Okay, so GPT-3 is not a machine translation model. It's something called a language model. So what's different about language models is that they're usually monolingual, in the sense that they're not really trained to look at two different sentences from two different languages and then translate between each other. What they're trained to do is look at data from one language, and then they're usually trained to predict the next word. So you say something like, let's take one of the previous examples. John lives near a park and he often goes blank. And then you expect the model to produce there. And it's trained on data like this, and this time it's trained on billions of sentences because, it's easier to find, especially for English, it's easier to find that scale of data. And the idea is that if you train it on enough language data, the model sort of learns the language, and then you can make it do all sorts of tasks by converting it into a sort of fill-in-the-blank problem or something like that. And most famously, what you do is you give it some starting prompt, and then you ask it to then just keep predicting the next word, and that way you can make it like write an article or something like that. Now, GPT-3 is fairly good at this because it's looked at so much data. But there's still research on why it's this good. One of the things is that it's a very huge model in the sense that it has what we call parameters, weights, and things like that you train in deep learning. It's very, very big. So it also tends to memorize a lot of the data that it has seen. But it is still quite creative. It can get, novel and things like that. It can give you what sounds pretty fluent. But if you look at it carefully, or if you make it, let's say, produce more than 100 lines or something like that, it starts to lose the thread a little bit. So that's a problem called coherence, right? The sentences individually make sense, but then you start putting them together and the whole thing doesn't quite form the story that it should. So humans, right, they write an article, there's a structure, right? They'll give you an introduction, they'll give you examples. All that is not really there when you make a GPT-3 produce a long text. So at the document level, these things start to matter again. So one of the things I did was also to try and build another model, which could tell you how coherent text was when a model like GPT-3 produces text. If you could also evaluate how coherent the overall text is. So that's something I worked on as well.
Okay, so I wanted to ask you, if I showed you two documents, one in, let's say, English, and then, let's say we are translating to English. So one, let's say, in Malay, and the other one is in English, the translation. So how would you evaluate this translation? How would you be able to tell whether it's from a human or a computer? Do you look for certain clues? How would you evaluate that translated document?
Right. So let me start with would you be able to tell if it's human or machine? So the problem with that is, as a human, you can So you can tell sometimes, not always. Because, like I said, they are quite good. Like, if you don't need information from the previous sentence, and if it's a pretty straightforward sentence, machine translation systems are quite good. They are at the stage now that they will produce decent translations that are useful. So you won't always be able to tell if it's a human translation or a machine translation. So that's, that's going to be hard. But yeah, if you look at the document level, then there have been studies that show that if you put, humans are quite good at telling them apart. If you look at the document level. At a sentence level, humans actually cannot always reliably tell apart if it's machine or human. Coming to the evaluation part. So like I said previously, people looked at word overlap. Now, more recently, what's being done is people have realized that simple word overlap is not, good enough, but we still need to do it automatically, in the sense that obviously the best way to do it would be to get a bilingual speaker and for them to look at the, original translation, look at the machine translation, the original source text, and then tell how good it is, right? They can give you a rating or something. Ideally, that's what you would do. But at the scale that we're using translation today, and, the hope that we want to use it, it's not possible for you to do that kind of human evaluation. That takes a lot of time and effort and money. So ideally, you would want to have some kind of automatic evaluation, right? Which is why people used word overlap for so long. And they still use it, even though there have been so many studies saying it's not the best way to do things. Because, it's easy, and it's easy to do it across languages also. So what people have started to do now is build other models to do the evaluation. So you build a model that learns to do evaluation. So you train a model to do evaluation. The way you do that is you take existing scores from humans. So whatever scores people have produced so far, whatever human evaluation has already occurred, you take those scores and you take those, you take the original source and the machine translation, the reference or whatever. You give all of that to the model, and then you say, given this input, like given this source and this machine translation, this is the score you should be producing. And then you train the model to do that. And ideally, if you have enough data, the model's going to get good enough so it can start to predict human scores. So again, this is active research. So we have models that are now better than using word overlap. But of course, they're not as, they're not perfect. They're not as good as human judgments, but they're better than word overlap. So we're getting somewhere. So hopefully as research, goes on, we'll get better and better models for evaluation as well.
That's like Turing test territory, right? It's like, if you can train the model to discern between whether a machine did it or a human did, then can you tell if that was a machine or a human? It's like...
Okay, so can you tell us more about this word overlap method?
So, okay.
You're overlapping words in the same language.
Right. Okay. Right, you are overlapping words in the same language. So you're looking at English, and then you're looking at a human translation of the original source, and then you're looking at something the machine has produced, and then you're going to check how many words overlap between the two.
But humans also can make mistakes.
Sure, yeah. I mean, that's also another problem, in that when you're looking at the human translation, they're not always going to be perfect either. So sometimes humans will make mistakes in their translation. So one of the problems with using word overlap is that you're implicitly trusting your human translation to be the best, and then you assume that it's the absolute. So for example, if you were to use a synonym, right? If I say, but I don't want to go, and then you say something like, however, I don't feel like going. It's at the end, it could mean about the same. It's not necessarily wrong, but you only overlap about 2 words there. But the whatever meaning you're conveying is the same. Right, and in the opposite example that I gave was when you had only 1 word wrong, like when you say like it's over there versus she's over there. There's only 1 word wrong, but then whatever you're conveying is completely different. So both of these cases have problems when you do word overlaps, right? So that's the reason why we want to use another model. The reason using another model can help is that once you turn it into a trained model, they do tend to look at, let's say, synonyms and things like that. So they're able to sort of be slightly better than just doing plain matching. They're able to tell that, okay, these 2 words are similar in meaning, and they can learn to, give it a higher score because of that.
And does it depend that if you have 2 languages, oftentimes one of the languages is much more concise, right? So if you can say something in English with like 5 words, you can say something in Malay with maybe like 2 or 3 words, right? So how do you, if you use the old method, which we've established as not great, right? How do they deal with that?
Right. This is a bit of a complicated thing. There's something called tokenization in language. So what you do is generally you split all of your words you usually do that because spacing is a different, so not all languages have spacing. So for example, if you've seen Chinese text or Japanese text, they don't actually use spaces in their language. So a concept of a word is very fuzzy in these languages. So when you're trying to do some sort of word overlap, or even when you're giving the input to a machine, you're saying that this is English and this is Chinese, you're giving it English words which are separated by spaces, and then there's Chinese text not separated by spaces. It doesn't really know which word is like aligned to what, right? You don't have this information. So this is also like sort of active research, but what people do is they split the words in Chinese using something called a tokenizer. So people again train models to do this, where the text gets split up into words, which would make sense to like, through some heuristics and things like that. And the hope is that these two would align. So when you do these kind of word overlaps, you also do this kind of tokenization. So you break up the words into like different components, and then you try to match those. But you're still right in the sense that at the end of the day, if you have more words in some language and fewer words in others, then they won't always, they're not always going to align. But when you do this kind of word overlap, you're doing it in the same language. You're not doing it across languages, right? So you're comparing a machine translation in English to a human translation of the same source in English. So then you don't really have the length of words, but then it is possible that a machine gives you a shorter translation, or a human has a longer translation. So the calculation also accounts for length, and it has some penalties if the machine translation is too short and things like that. It's a little complicated, but let's not go into like the formula, but they do account for these things.
I guess now we can maybe dive a little bit deeper into what you have been personally doing in your work during your PhD to tackle these problems.
Okay. As I mentioned before, one of my main contentions was that we need to be doing better evaluation. And one way to do that is to build a model that will do the evaluation for you. But another thing that I also wanted to say is that doing a sort of holistic evaluation, right? Like just telling you how good the translation is overall is useful in some ways. Like for you to know, okay, is this model better than that other model? And that's useful for that sort of comparison. But to specifically know the weaknesses of your model or strengths of your model, what you need to do is more fine-grained evaluation. You need to do specific tests, not just get an overall number of how good the translation is. So what I was trying to do was to build test sets for things that I thought people should care about. And because I was specifically working on document level, I was trying to tell people that you should be looking beyond the sentence level. What I was doing was building targeted test sets for all of the things that we might care about. So pronouns, for example, is something we care about. So what I did was build a test set where I had all of these different sentences with pronouns in them, and the previous sentence, and 2 or 3 previous sentences before that for context information. And then I picked out these cases because I thought these would be hard for machine translation systems to translate. And what I did to get that information was I actually ran a whole bunch of machine translation systems through lots of data. And then I saw where they made mistakes. And based on that, I built a test set to find, saying that these are hard cases for machines to translate pronouns. And then after you build that test set, it's basically anyone can run their system on this and see how their machine, how it does on this test set. So then they know that, is it using the context? Is it actually doing as well as it's supposed to? And not just, you can still improve your machine overall, but is it improving specifically the way it's supposed to if you're using extra information? So it could be pronouns, it can be coherence, it could be lots of other things which are going to be like discourse connectives. These are things like if, however, but, and so on. So these also are, things that go beyond the sentence level. So what I did was collect like different kinds of test sets for this. And initially the idea was just to do like a straightforward yes or no, like is the machine translating this correctly or not? So, but even that gets simplistic, right? So as a first step, that's good because your test set is targeted, so it's fine. But then the same problem that applies to word overlap also applies here. So if you're just checking if it is right on this pronoun or not, it's possible that it rewrote the sentence in a way that you don't need a pronoun. So if you change from active voice to passive voice, for example, it's possible you completely skip the pronoun, but it's not necessarily wrong. So then that's something you have to account for. So this does tend to get more and more hard to do once you start to look at all of these cases. So what I did was also try and build like model-based solutions for this. So what if I had all of this data? I knew that all of these machine translations are they're not wrong, they're correct, but they don't match the reference. So what if we took all of this data and then tried to train a model saying that this is good, this is wrong, this is also correct, and so on. So that's mostly what I worked on for across all of these different things like pronouns and coherence and so on.
Mm-hmm. And what was your motivation when you're trying to extract these test sets? Because I work in optics and we have like very clear cut, like a test slide, right? For example, it has a certain pattern. If the camera can see that pattern, it works great. If it can see it really well, then it works even better, But like, I imagine that's not so simple if you're trying to develop like a language test set. Like, are there certain sentences that poke the model in certain ways that you want it to?
Right. I mean, I took a more like general approach because the idea was that this test set should be useful like to everyone. But yeah, I did do something similar. So like I said, I was looking at so there is an annual sort of machine translation competition, let's call it that. It's a conference where lots of different people submit their machine translation system outputs. So what I did was I went through all of these outputs to see where they were getting things wrong. And then I was sort of filtering all of these test sets. I actually filtered them over, I think, about a 10-year period or something like that, and then looked at all of the errors that showed up. And then I consolidated all of them to build the test sets. Yeah.
And how big of a text are we talking about?
So so it really depends on how common the thing that you're looking for is. So pronouns are relatively okay, they're common. So you can build, let's say you can get 4,000 to 5,000 samples or something like that over some years of data. Like I said, in general, parallel data is hard to come by. So, 4,000, 5,000 is a good size. But if you're looking like something like connectives, when you're looking for things, if, however, but, so these things don't occur that often. And it also really depends on the kind of data you're looking at. So if you're looking at, for example, subtitle data, this is quite common. So you have, movie shows and then you have subtitles in different languages. So these will tend to be parallel, right? So those kind of data will have lots of like connectives, they'll have lots of pronouns and things like that. But if you look at news articles, which is actually one of the more common kinds of data we have because people tend to translate news across different languages, and then you also have like UN parliamentary discussions and that sort of thing which get translated across different languages. So this tends to be the most common kind of data. The problem with that is that news data will not have that many pronouns, it's not going to have that many connectives and so on. So this is also a reason why machines are not good at this, because this is the kind of data they see also. So they don't see enough of these things. So if you comb through those, you're not going to see enough. So one thing is connectives generally don't occur that often, and then they occur even less often in news data. So all these things kind of restrict how many samples you can come up with for testing, and they restrict even more the kind of samples you have to train models.
And what about novels and books, stuff like that? Are they big enough of a data set? So
the thing is that the ones that are in public domain for people to use are probably not all that many. But yeah, so books, book corpus, I think is used mostly to train language models. I think people haven't really used it to train machine translations. I'm not very sure about this, but they may have. Unless, if they are in the public domain, they may have been used. But I think the problem with books also is that, especially if it's human translated, it's a very long document, right? So the capability that people let machine translation systems look at that long document is still not quite here. Again, with books, if people are translating, a really good translation ideally would take things like culture and that sort of thing into account. So they change a lot of things that makes things. It won't necessarily mean you have parallel data. So you don't necessarily have this sentence exactly translated. Like it's possible that, 2 or 3 sentences got combined into one here, or one sentence got expanded into 2, that sort of thing. A good translation would do that to make sure that the readers in that native language will understand that book. And, the emotions that the, author wanted to convey are conveyed and so on. So that means they have to sometimes take creative liberties with the way they do the translation. But unfortunately, that also means that they're not like one-to-one correspondent, which might mean that they're not very good for training models. I mean, ideally, this is what you want your model to do also, but we're very far from that scenario. Like, we want to get there someday, but we're not there yet.
Is this also a problem with, because I imagine subtitle data is very colloquial, right? Like if you're watching a movie and you have subtitles in like Malay and Chinese, they want you to understand for
Right.
sure, right?
Yes, yes. So I think so recently there were some issues with like the Squid Game subtitles and things like that, something you may have heard. So what often happens is that like in Korean dramas, you have all of these words that people use, and when they get translated to English, it's hard to explain the cultural context of it. So what Netflix will often do, or the subtitles will just have the names of the people. So one thing that I remember someone was talking about was this whole are you familiar with Squid Game? You might have seen it. So there's there's this main character and this Pakistani worker or something like that, and they sort of become they share a bond and everything. So the main character tells this guy to call him Hyung, which is a word for older brother. So he tells him to call him older brother. But in the subtitles, it just says, call me by name. So it just shows his name. So you think that they're friends now and this guy is calling him by his name, but it's a much bigger context there where this guy is his younger brother now. So the betrayal is that much more worse because, they have that bond which, he's shared as a brother, not just as friends. Now, all that context is lost in the subtitles when you look at the English version. So this is something that people were upset about. But the problem is if you write Hyung there, it's impossible for you to explain all of that in subtitles. You don't have enough space. And one of the problems with subtitles also is there's usually restrictions on how long they can be because people need to be able to read all of that text in the time that the scene is on the screen. So, subtitling is actually really hard in terms of translation because they have all these restrictions. So, they have to get creative the way they do it. But this does mean that it's a little harder to train models with it. But ideally, one day we want models to produce these kind of translations as well. And, hopefully the idea is that we collect all of this data and in a few years we have so much data that we can feed all of this into the model and the model will learn all this.
That's a really good example, and belated spoiler for anyone that has not seen it.
Oh, I'm so sorry about that.
Okay, so there's a long way to go.
Mm-hmm.
Are your test, what do you call them? Your
Test sets.
Mm-hmm.
your test sets.
Mm-hmm.
Are they publicly available
Yes.
for anyone developing language?
Yes. So it's all published work. It's all publicly available. I have a website, a GitHub page that has all of the models that I've developed, all the test sets that I've built, and I've tried to build them across different languages as well. So they are available for a wide variety of languages, especially the pronoun one. It's very I think it covers about 15 language pairs or something like that. Mm-hmm. So it's available for different languages. That's definitely a problem. Like a lot of the problems I've described today are problems like specific to English. Once you start going into other languages, you have many, many more problems.
Mm-hmm. And what are the translation models developers are expected to do after running your tests? So let's say they run tests and they see like there's a lot of, like you say, on a grand level, it scores high when you do the word overlap.
Right.
But there are very small parts
right.
where they...
So let's say that it's getting pronouns wrong consistently or something like that. So, the idea is that if they realize there's a problem in a particular direction, they can focus their efforts in that direction. So either they realize they need to collect more data with pronouns in it and then, start training the model with that. Sometimes it can be as simple as upsampling the data, which means that, let's say you're training your model on 10 million sentences, and then only 2 million of that is pronouns. Maybe you just double that 2 million, just copy it all over again, and then you now train it on 12 million, and you have 4 million pronouns. You're just doubling that data. Sometimes something as simple as that can help. Sometimes you may need to collect additional data, pay someone, get data or something like that. Or you could even do this in an architecture way, not use data. Maybe you go into your model and then you add if you're familiar with deep learning terms, there's something called a loss and an objective function and things like that. You can upweight the loss so that, it specifically focuses on pronouns, for example, and says, okay, every time you're looking at pronouns, you try and make sure that the model's paying extra attention, something like that. So that's also a possible solution. So, there are some ways to improve these, but again, it's not going to be that easy or straightforward. At the end of the day, there are lots of limitations with data and things like that. But knowing where your problems are means that you try to concentrate your efforts there. If you don't know that those are issues, then people continue to think that, translations are just getting better and better. But now we know that they're not. So then that helps us so that we scale back and try and see if we need to be doing targeted improvements instead.
So, and they're able to target with another one of your models that helps them evaluate? Because you have the test set, they run the test set, but then how do they interpret the results of their model? Or how do they know how well their model did when they just fed the data in?
Oh, I didn't really understand
So
what you mean.
let's say they've developed a model, right? And you have developed the test set. They put in the test set,
Right.
and the model gives out a translation. So now how do they, like, they know the ground truth,
Right.
but they also know how they did it. So how do they know that, oh, our coherence is bad, but our word to word is good? Or
Right. So
on.
that's what the targeted test sets are for. So the idea is that your test sets are, specifically looking at one thing. So all the test sets, with the pronoun test sets only has pronouns. The coherence test set, it only has pronouns, as in every single sentence has a pronoun in it. And, it has the previous two sentences or something to be helpful. And then you're checking how well it does on that sentence. So you don't have to look at the overall translation. Like I said, a simple way would be to just check again, does it produce the same pronoun that's in the human translation? Now, that's like one step. But like I said, that can still have problems, because if you have passive voice, for example, it doesn't produce a pronoun, you would mark it as wrong, even though it might be right. So then that needs an improvement on the evaluation, for which you might need to use a model. So I've tried to work on both counts. So one thing is to build a test set so that they can do a simple accuracy check. Is it the same pronoun that's in the human translation? But if you want to do something a little bit more sophisticated, account for facts that the model could be right or wrong, even if it overlaps with the human translation, then you have to have a model-based evaluation. And I've tried to work on that also. But at the end of the day, none of these are perfect. There's still going to be things that they're not going to get right. But this is how research works, right? So hopefully things will just keep improving as we go on.
And are you still working on this problem?
Yes, I mean, sort of. So I've currently now moved on to industry. So I'm a research scientist at Rakuten, and they do work on machine translation. So I've sort of continued to work on that.
Okay. So maybe we can get into the future of this research field. Look, so how do you see the models, and how do you see the tests developing going forward?
So one of the things about evaluation is that it does have to evolve with the model. So let's say that in an ideal world, we end up with a lot of data, a lot of document level data, and then machines are now really good at looking at all of the information and producing really good translations. They're still not going to be perfect. The next step is now we find what's wrong with those models. So at every step, you're going to get better at one thing. There are going to be problems with other things. So this is, the kind of evaluation that I did was, very specific. There are lots of other things that machine translation systems are still bad at. So for example, robustness is a very common problem with deep learning models. So for example, if you say John lives near the park, you get some kind of translation. And you say John lives very close to the park, you get a completely different translation. They mean very similar things, but sometimes that can, sometimes it's even as worse as you add a full stop at the end and then you get a translation. You remove the full stop, you get a different translation. Even that happens. So, there are lots of different problems with models that are beyond the specific kind of evaluation that I've been working on. So, I'm sure there'll continue to be more problems. So once they get good at, document level translation, we'll have more problems that'll come with it, and then we'll evaluate those. And the idea is that these two sort of develop each other, right? So evaluation will point out problems, and then machine translation systems should get better based on that. And once they get better, evaluation should evolve to start pointing out the new problems, and then the machine translations get better, and so on and so forth. And then ideally we reach some kind of, black hole or something.
Singularity of translation.
Singularity, yes.
Okay, that was actually my next question. What is that? What is the end game here?
Well, ideally, you should then be able to translate really hard things like legal documents or something like that. So that's usually where, where it's really hard for you to trust a machine, because things like legal documents, they have to be exact. You cannot have, things, you can't even use synonyms sometimes, because there are legal terms that mean exactly what they're supposed to be. And you can't have contracts that are translated into a different language and then someone's signing it and it's legally binding and then it says something else. So ideally, the idea is that we have a world where we have all of this data, and then if we need to, convey that to someone who speaks a completely different language, we're able to do it in a way that conveys all of the information that you want it to exactly the way it is supposed to be said, and then also do it in a way that is fluent in the language that they speak. So these are the two sort of yardsticks for machine translation. It's called adequacy and fluency. So how adequate is it in terms of the information it's conveying, and how fluent is it in the language that it's conveying it in. So ideally, this is going to be perfect on some day, so that no matter what, you have news reports, you have, let's say, business reports, you have financial reports, legal documents, subtitles, movie subtitles, anything. You have all of these things. Ideally, you will just be able to simultaneously translate all of this into multiple different languages, which is also because different languages are at different paces. So some languages are really lagging behind. So ideally, you'll be able to do this for whatever languages you need, and then be able to do it well enough that everyone can understand what you're trying to say. So this means that people have access to so much more information that they didn't have to before, and they can they get opportunities, hopefully, and then even something as simple as having access to a different language movie or TV show, something like that is a huge thing, right? Especially if you've seen Squid Game and stuff, it united a lot of people and things like that. So even these are small things that do tend to enrich your life. So hopefully one day we'll have that across languages and reach more people.
So you mentioned there has to be some sort of iterative process, progress, where you have the model getting better and then the evaluation getting better. So since you work on the evaluation, what kind of progression do you see within evaluation? Like, you test certain parameters today, and then let's say a bunch of models use your evaluation, they get better. Then what does the next version of your evaluation algorithm look like?
Well, it should get harder and harder, because the models are not going to just they're not going to solve all problems. They're going to get good. Let's say they look at the test sets and they think, okay, if you have a problem with this, we'll add more data or loss or whatever, and then they get better. So they're still going to make errors in certain kinds of cases. Right? You can always think of cases which are hard enough that the model is going to struggle with. So there's the things we talked about early on about common sense, world knowledge common sense versus, let's say, local context common sense. So it's possible that the model learns to look at the complete local context. It still doesn't have common sense knowledge that comes from interacting with the world. So that sort of thing, you can still, in the ideal case, you want the model to know that also. So then you could find examples where the model fails in those cases. So, and it's not just pronouns or coherence or whatever. Like I said, there's also robustness and all of these problems. So there are lots and lots of things that, the model can still get wrong. And, your examples should get harder and harder as the model gets better and better. So, I mean, it could look like an impossible scenario where you're giving a model that, a sentence that no one would reasonably produce. But that's not really the case. If you think about it, almost every day there's at least one sentence you produce, probably, that you've never actually produced ever in your life. So that's the beauty of language. It's so productive that people produce sentences that probably no one's ever said before also. And this happens all the time, right? So you can't expect that the model just looks at all possible examples in the world and then it's just going to get perfect. It's going to have to learn to look at sentences that no one's ever produced before and still produce a good translation. Humans are able to do that. So, that's a high bar, and, evaluation is also hopefully going to keep up with that.
So you want to eventually teach the model abstraction or something like that.
Right. I mean, that is the goal. So the idea is that you have a model that's general enough that it's going to handle all examples and not just something that it has seen before. Because humans are able to do that, right? We don't, that was one of the cat dog examples that you gave me before. You show humans one cat, it's usually good enough for them to recognize the second cat. But, you need to give machines hundreds or 200s or thousands of pictures of cats for them to know what a cat is. So humans don't need that. So ideally, you have to get the model to generalize enough that it doesn't have to see a particular word or sentence before for it to produce a good enough translation of it.
So far we've been talking about evaluation models in the context of translation models, or what do you call machine translation. But couldn't it also be the case that these evaluation models are used independently to evaluate human translators? Are we at that stage?
Well, I mean, yes, we could technically use them. Some of the models could give you a score. But the thing is, humans do tend to sort of be the baseline or the way we produce the data itself. Okay. So what happens is that if you've trained a model to, sort of guess human scores, for example, then chances are it's sort of going to be biased towards thinking human translations are really good, because that's the data you've taught taught it. You've said this is good and this is bad. And so it's going to think all human translations are good. So, it's not impossible to do. That would mean that all this means you just need more data, which means you need data where human translations are good, and then you need human translations which are bad, and then you need to tell the model this is good human translation and this is bad human translation. But then someone's going to have to sit and do this also. So at the end of the day, it all comes down to how much data you have.
Right.
Can we step back like all the way when we were talking about the general idea of this concept? Mm-hmm. So if we go back to like GPT-3, right, where GPT-3 has learned the English context really well. Like
right.
It's a really massive network, and it takes a lot of computing power, but it just does it, right? It's pretty good, and I think there are like a lot of examples where people are like writing actual stories with GPT-3, and it's pretty not bad. So could you have hypothetically another GPT-3 for every language?
Yes.
And then just like merge them, and then they're like the perfect translation because they both understand their own context really well.
Yeah, so that's how humans. So even if you look at humans, right? You pick someone who's a native French speaker and another person who's a native English speaker. Does that mean they can communicate with each other?
That's a fair example. Yeah.
So I mean, yeah, you're gonna have to tell them. You'll need parallel data. You need to tell them, okay, this is apple in English and then this is pomme de terre or whatever it is in French, and then that you start to have a shared concept, and then you realize that it's they're both apples and then they're called by different names in different languages. So that information you need to insert. One thing about GPT-3 is that a lot of these models, the really big models, they tend to be trained on all of the data that's on the internet. So they do tend to pick up some amount of parallel data as well. Because, for example, Wikipedia, right? They tend to have articles that are in different languages, and they might not be exact translations, but they are pretty good parallel data. So then if you train GPT on all of the data that's on the internet, it does tend to see some of this kind of data. So if you give it English and then ask it to translate to French, sometimes it does produce a reasonable translation. It can do that, but it's mostly because there's contamination in the data that it's been trained on. So it's not specifically trained for this, and it's not going to be as good as another machine that's specifically trained to do this. But, we are sort of, in general in NLP, there is a sort of move to do this, to build these large, massive scale language models and then train them further to do all of these downstream tasks, which could be machine translation or summarization and lots of other things like that. So that is where the research field as a whole seems to be headed. And I think it also makes sense, because this is one way to give it that kind of common sense knowledge that we were talking about. Because by pre-training it on lots of these English data, what it's done is learned all of the knowledge that's on the internet, all of the internet. So then it has some pre-existing knowledge. And then once you train it further for other tasks, it may be able to use this pre-existing knowledge. But of course, this comes with lots of other problems. The internet is a very toxic place, which means it's picked up a lot of toxic language. It's picked up racist biases. It's picked up sexist biases. All of these is also there are people who actively, do studies to show the kind of problems that exist in these models. So, somebody has to spend time cleaning the data that's fed into these models and all of that. So that's also an active area of research where people are trying to make sure that, we're not building these, toxic models as well.
It's like a very applicable field of research.
Is there anything in your work that we haven't touched on? Something interesting that you'd like to share, for example?
Yeah, so I mean, that also means going into detail is I think we've pretty much covered everything that I worked on except for the, absolute details.
I do have one final question.
Okay.
Because this is such an interesting topic. So let's say you have these two specialized models, and you have this really good French person, or a person that can speak French really well, and a person that can speak English really well. But if you were to ask the English person, if you give them some very basic French, or you give them a dictionary, and you ask them to just fumble their way through French, the French person would be able to correct them really well, right? And that that English person, if they have that, if they don't have human fatigue, they could just exponentially get better with that
Right.
really good feedback.
Right. So this is, you go to a language class and then they're teaching you. But then, okay, so this can happen if the French person is able to reasonably guess what it is you're trying to say, which is possible at smaller sentence levels. But if the French person is giving a legal contract in English, they're not going to be able to guess very well what it is that they're trying to say, right? So, I mean, again, that's why models are pretty good at some of the basic stuff. And then once things start to get complicated is when even they start to break down. So, but this is something people have actually tried. So there is, there was a paper that worked on this. There's a publication where they had these two separate language models. One was French, one was English. And then they had like another sort of mediator where the English would try to produce French. And then the French model would give it feedback on how good the French was. And then the English model would like sort of try to improve. And they try to build this, and like if you train it for long enough, it does get to a reasonable, to a level where it's reasonably good. And in this way, you can build like unsupervised models in the sense that if you don't have parallel data for two languages, you only have monolingual data. Maybe you can sort of build a machine translation system by doing this. So they didn't really do the study, unfortunately, for the languages that really need this sort of thing. They did the study for English and French, if I remember it correctly. But of course, that means that they cannot beat models which were trained on that kind of parallel English-French data, because the models that are trained on that are always going to be better. So maybe if you have a language where you don't have any parallel data at all, and you could have two monolingual data models and then try to improve them. But I mean, at the current state that we are at, that your time is better spent building that kind of parallel data, because that's much more useful to everyone. Other people who are doing research as well. And it's always useful for a language which does not have enough data to have more data. So that also increases visibility for that language and then encourages more people to work on it. So usually I'm the kind of person who's data is always good, make more data, that sort of thing. But there are people, who believe that we can solve problems with models, which isn't necessarily wrong, just a different perspective.
Right.
And is that the assumption that we need more data? Is the valid assumption? Do we see trends where more data lead to more accuracy?
So yes, I mean, in general, the more data you have, the more varied data you have, the better your accuracy is. I mean, if you have the same kind of data, if you have like I said, if you have 10 million sentences, you just double that to 20 million, doesn't really help. But if you have another 10 million, which is like different from the original 10 million, you're giving the model more varied examples. So the model is seeing more data, more differences in data, and then the idea is then it's able to generalize better because now it's seen more varied examples. So then you give it, a new sentence, then it's seen more examples and is able to translate better. So if you have more varied data, then yes, it does tend to improve models. And even things like the big models like GPT-3, for example, they are like there's another model that's better than, people claim is better than GPT-3, and a model that's better than that, and so on. What they're all doing is increasing the size of the model, the capacity of the model, let's call it that. And that also seems to be improving things at a certain level. People do think that it's going to cap out at some level, like after you have a humongous model, it's not going to get any better. That's also possible because, your data has to keep up with the model size as well. At some point, let's say you have a model that's so huge, it's memorized all the data that you gave it, and then it's going to hit a wall after that. We don't know if it means that if you train a model, huge enough model, on all of the data that's available in the world, does that mean that it's going to be a perfect translation system? We don't know.
Yeah,
hopefully I'll be there at the time to poke holes in it.
I guess then the follow-up question would be, do we have enough data?
We don't. That's one of the biggest roadblocks to why machine translation systems aren't perfect yet, and also why document level translation is not possible. So like I was saying, getting document level parallel data is really hard, and it's even harder for certain languages which are not all that popular. So if we get more data there, then we're definitely going to have models improve. Like I was saying, if you have that kind of supervision with parallel data, those models are always going to be, currently they're much better than models which are unsupervised. Of course, if we have a breakthrough in unsupervised learning and then suddenly they're able to build much better models, then maybe data becomes obsolete. But currently we're not there yet.
But this is kind of funny because you need more data, which means you need more people to do translation, which at the end will lead to these people losing their jobs.
Right, exactly. So I mean, that's unfortunately how I guess things are
But right now you need them. They're the most valuable.
So right now there's sort of a lot of the machine translation systems are helpful to these people in the sense that they produce an initial translation that the translators can correct instead. So a lot of people do that. it's helpful in two ways. One way, it does reduce a substantial effort for the translation, for the people who are doing the translations, and also it helps the people who are building these machines, because instead of having, let's say, a source and a human translation, you now have a correction of the machine translation, which is also really useful data to have. So you could, like, there are people who work on something called post-editing, where they build models which will take machine translation systems as input and then correct that. So, because that could be like a slightly easier task. Rather than doing a complete translation, you're sort of breaking down into two steps, where you first produce a reasonable translation and then correct it so that it's more fluent, or, makes a little bit more sense. So that's also like an active line of research. And this kind of data where people correct the problems rather than, produce a completely different translation is also useful data. So that's also something people collect. But yeah, I mean, that still puts a lot of people, like, doing,
but that's,
like,
I guess,
building all
really
these efforts.
far future.
Right, I mean, it's quite far in the future, because one thing is, this is all translation, but then people are also more, like, human translations are particularly useful when you're doing interpreting. So this is when you're doing simultaneous translation. Someone is talking, and then you immediately produce the translation, and then someone talks, and then you sort of have these kind of parallel, or, like, someone's giving a speech, and then someone's writing the subtitles, like, simultaneously at the same time. So they are building machines for this as well, but those systems are not all that good, because especially when you have, like, all this time we've been talking about text, there's also speech, which is like a whole different dimensions that I'm not really familiar with, but then there are problems there, because a lot of the way speech works is that you first have to, you have to capture the speech and then correctly understand what the speech is, and then translate it to a different language. And there are going to be problems at each level of that. Sometimes you don't even get the speech right. And so, whatever errors you get at recognizing the speech correctly are now propagating into your translation. So, like, there's a lot of other problems that we're yet to solve. So this is quite far in the future.
Yeah, and transcripts are completely different documents. They're not written as a book or an article.
Mm-hmm.
Yeah.
Right.
Yeah, it's a completely different problem, I guess.
Yes.
Okay, that's very interesting. Okay, so at the end of each episode, we'd like to chat with our guests about their personal life, a little bit of their hobbies, what do they do in their free time, stuff like that.
What do you find yourself doing most often outside of research?
Oh, so I actually really like learning languages. So most of the time I do watch a lot of Korean dramas, by the way. I'm a huge K-pop and a Korean drama fan, and I picked up Korean by watching them. I've been for a few years now. So now I like try to read books in Korean and things like that, try and improve it. I've been recently learning Mandarin and Japanese as well. I'm very slow. But making some progress. So usually I'm like reading other language books or watching dramas in other language with the excuse that I'm learning the language. But it's like two birds, one stone, or at least that's what I tell myself. But
no, that does help. Yeah, I also picked a little bit of Spanish just from watching Spanish shows. So
yeah.
That does work.
Yeah, I do feel that as opposed to learning from a textbook, which is something I try to do, like when you're in school, they do try to teach you another language, and then you're mostly learning out of textbooks. And I got like fairly good at looking at text and like figuring out what it means, but I never actually learned to speak it. But I do find that if you try to watch shows and then learn languages from there, you tend to pick up like a lot of cultural context, you tend to pick up pronunciation, you get really good at understanding other people, and you can actually have conversations with them. And it's not really it's really hard to pick that up from a textbook. So like watching shows is a really good way to learn languages. Just don't watch subs over dubs.
Wow. I've heard that watching anime is not the best for learning Japanese.
Oh, really?
Because people don't talk like that in real life. Like in Japan, people don't talk like that.
I mean, anime maybe not. Because, I mean, in some sense, anime is sort of fantasy. But if you're watching it for language learning and then also sort of watching, let's say, Japanese regular shows with, like, people in them, with, like, people problems or something like that, then you probably have, like, a much better idea of how people talk. Of course, I mean, any media that people are putting out is not, like, a very accurate reflection of how people live. So there's always that. But you still, I think, get a better idea than you would get from books or from even like Duolingo or something like that. Like Duolingo is really like I use Duolingo like every day. It's really good for building vocabulary and like learning how to read and stuff. But it's not very good to teach you to speak or to understand when someone else speaks. So it has to be like a combination of everything.
Cool. I guess that's everything for this episode. Thank you very much, Jwala, for joining us.
Yeah, thank you so much for having me.
Bye, everyone.
Bye.